The observable universe ends at 46.5 billion light-years in every direction. Beyond that boundary, space recedes faster than light can travel. We will never see what lies past it. This is not a technological limit. It is the geometry of space-time itself. Most people assume the universe is 13.8 billion years old, so light should have traveled only 13.8 billion light-years at most. But the observable universe extends to 46.5 billion light-years. This is not an error in measurement. Space itself has been expanding while light travels through it. When you look at the sun, you see it as it was 8 minutes ago. Light takes 8 minutes to cross the distance between the sun and Earth. Jupiter appears as it was 40 minutes in the past. The nearest star beyond our sun shows itself from 4 years ago. Every object in the night sky is a window into the past. Looking outward in space means looking backward in time. The universe is not something we observe in the present. It is something we reconstruct from old light. Distance and time are locked together by the speed of light. Light moves at 300,000 kilometers per second. This is not simply fast. It is the maximum speed at which information can travel through space. Nothing moves faster. No signal, no particle, no influence can exceed this limit. Because light takes time to cross distance, everything you see is delayed. The stars visible tonight sent their light decades, centuries, or millennia ago. Some of those stars may no longer exist. Their light continues traveling toward us long after the source has gone dark. We see their history, not their present state. The farthest galaxies we can photograph appear as they were more than 13 billion years ago, when the universe was less than 1 billion years old. We see them in their infancy. Those galaxies still exist, but they have aged 13 billion years in a direction of time we cannot observe. A photon leaving a distant galaxy 13 billion years ago began its journey through a universe that was smaller. As that photon traveled toward us, space stretched. The galaxy that emitted the photon moved farther away while the light was in transit. By the time the photon arrives here today, the galaxy is now over 30 billion light-years away. This happens because space expands. The expansion is not galaxies flying through a pre-existing void. Space itself increases. New space appears between galaxies. The fabric of the universe stretches, carrying galaxies with it. The galaxies remain mostly still relative to the space immediately around them. The distance grows without the galaxies moving. This is difficult to picture because we do not experience space as something that can stretch. In our daily lives, a meter is a meter, but on cosmological scales, space is dynamic. This is why the observable universe is larger than 13.8 billion light-years. Light has been traveling for 13.8 billion years, but it has been crossing space that was expanding the entire time. The sources of that light are now much farther away than the distance light could travel in a static universe. On small scales, like within our bodies or our solar system, gravity and atomic forces hold things together. But across the vast voids between galaxy clusters, there is nothing to stop the stretching. Space expands at every point simultaneously. New space forms between galaxies every second. The universe does not expand like an explosion with galaxies rushing outward from a center. There is no center. Every point in space sees itself as the middle, with everything else moving away equally in all directions. Einstein's relativity sets a firm speed limit. Nothing can move through space faster than light. No object with mass can reach that speed, let alone exceed it. This law has been tested extensively. It holds in every experiment. But space itself? Space is not bound by this rule. You see, space does not move through anything. It has no velocity in the traditional sense. It simply expands. And there is no law of physics that limits how fast it can expand. A region of space far enough away can move away faster than light without breaking relativity. This seems impossible at first. But the key is understanding that the galaxy isn't moving through space. The space between us and that galaxy is increasing. Imagine a photon leaving a distant galaxy, traveling toward Earth. It moves at the speed of light, crossing space, 1 meter at a time. But ahead of that photon, space is expanding. The distance the photon has to cross gets larger while the photon travels. If expansion is slow, the photon still makes progress. It gets closer to us with each passing second. But if expansion is fast enough, the photon can move at full speed and still lose ground. It runs forward on a surface that stretches faster than it can travel. At a certain distance from us, the expansion beats the speed of light. Photons sent in our direction from beyond that distance will never arrive. They travel through space that stretches faster than they can cross it. The photon is not slow. The space is just too dynamic. This is why the observable universe has a boundary. That boundary is the distance where expansion overtakes light. Beyond that line, we are completely cut off. Events there cannot affect us, and light from there. If we look back far enough, we reach a different kind of limit. 380,000 years after the Big Bang, the universe was filled with hot plasma. Photons could not travel freely through this dense fog. They scattered constantly off charged particles. The universe was opaque. This was a time before stars, before planets, before the vacuum was clear. Light was trapped in a thick soup of protons and electrons. No image could form. No information could cross space. Then, the universe cooled enough for atoms to form. Electrons combined with protons. The plasma cleared. For the first time, photons could travel across space without scattering. The universe became transparent. The light released at that moment is still traveling through space today. We detect this ancient light as the cosmic microwave background. It fills the entire sky as a faint glow of radiation. This is the oldest light we can observe. It forms a boundary at the edge of our observable sphere. Even with perfect instruments, we cannot see what happened before this moment using light. The universe was opaque before atoms formed. This is the inner wall of our visibility. It is a physical curtain between us and the earlier universe. The boundary of the observable universe is not a physical edge. There is no wall, no surface, no marker. If you could travel to that boundary and look around, you would see galaxies in every direction. You would not notice anything special about your location. From that new position, you would be at the center of your own observable universe. You would have your own horizon, 46.5 billion light-years away in all directions. Galaxies invisible to us would be visible to you. Galaxies we can see would be beyond your horizon. The boundary is not a place. It is a relationship between distance and time. It is the distance at which light has not had enough time to reach the observer since the beginning of the universe. The galaxy at the edge of our view does not know it is at our edge. From their perspective, we are at the edge of their observable universe. Both perspectives are correct. The universe has no preferred center. Every location sees itself surrounded by an equal sphere of visibility. This symmetry has a profound implication. If every location has a finite observable radius, then there must be regions of the universe beyond everyone's horizon. There are galaxies that exist, but will never be visible from our location. Their light travels toward us, but it will never arrive. The space between us expands too quickly. We are cosmologically separated, not by choice or by technology, but by the structure of space-time itself. The expansion of the universe is not constant. It is accelerating. Distant galaxies recede from us faster today than they did 1 billion years ago. This discovery came in 1998 through measurements of distant supernovae. It was unexpected. Most cosmologists had assumed expansion would slow down due to gravity pulling everything together. Instead, observation showed the opposite. The universe is expanding faster now than it was in the past. The cause of this acceleration is called dark energy. We do not know what dark energy is. We know only that it exists because we measure its effect. Dark energy appears to be a property of space itself. As space expands, more dark energy comes into existence. The more space there is, the stronger the acceleration becomes. Dark energy creates a feedback loop. Expansion generates more space. More space means more dark energy. More dark energy drives faster expansion. This process does not weaken. As far as we can tell, it is permanent. Dark energy is not a temporary force. It is woven into the fabric of space. This has consequences for the observable universe. As expansion accelerates, the boundary will eventually stop growing. Galaxies currently visible will cross the horizon and disappear from view. Their light will redshift until it becomes undetectable. From our perspective, those galaxies will fade into darkness. They will not vanish because they were destroyed. They will vanish because the space between us expanded too much. At roughly 14 billion light-years from Earth, there is a distance called the Hubble Horizon. Beyond this distance, galaxies recede faster than the speed of light. Light emitted from those galaxies today will never reach us. The photon makes progress through space, crossing it 1 meter at a time. But the space ahead stretches faster than the photon can close the distance. It is like a runner on a treadmill that accelerates. No matter how fast they run, they lose ground. We can still see some of these galaxies because we observe light they emitted billions of years ago when they were closer and when expansion was slower. That old light is still arriving. But the galaxies themselves have crossed a threshold. Their present state is permanently invisible to us. We see their past, but we are already cut off from their future. These galaxies still exist. They continue to form stars, evolve, and change. But we will never witness what comes next. The light showing us their current state will never complete the journey to Earth. We are separated by more than distance. We are separated by the rate at which space expands. Trillions of years from now, an observer in our galaxy will look up at the night sky and see almost nothing. The only visible galaxies will be those gravitationally bound to our local group. Everything else will have receded beyond the horizon. The cosmic microwave background will have faded into undetectability. The wavelength of that ancient light will have stretched so much that no instrument could register it. Future astronomers will have no evidence that the Big Bang occurred. They will have no way to measure the expansion of the universe. The sky will appear dark and empty. Future scientists will live on an island of stars, surrounded by darkness that reveals nothing. If they develop cosmology, they will do so with incomplete information. They will see a handful of nearby galaxies and an otherwise empty universe. They will have no reason to believe the cosmos was once filled with billions of galaxies. The evidence will be gone. We live in a privileged era. The universe is old enough that structure has formed. Galaxies exist. Stars have created heavy elements. Planets have cooled. Life has emerged. But the universe is still young enough that we can observe its deep past. The cosmic microwave background is still visible. Distant galaxies can still be detected. We can reconstruct the history of the universe from evidence that is currently available. This window is temporary. The evidence is disappearing. There is no intent behind this process. The universe does not hide itself. Expansion is a property of space. Acceleration follows from dark energy. The boundary of observation is a geometric consequence. Every photon that reaches Earth has crossed an expanding universe to arrive here. Each photon began its journey in a cosmos that was smaller and denser. As it traveled, space stretched. The galaxy that emitted it moved farther away. The photons we detect are survivors. They were emitted from the right distance at the right time to complete the journey. Photons emitted slightly farther away will never arrive. This applies to us as well. Other observers see us in their past, just as we see them in ours. A galaxy 20 billion light-years away receives light from the Milky Way that left here 20 billion years ago. But our galaxy did not exist in its current form 20 billion years ago. What they see is the gas cloud and early star clusters that would eventually become the Milky Way. They do not see the Sun. The Sun formed only 4.6 billion years ago. They do not see Earth. If they are observing our location, they are observing a past version that predates everything familiar to us. There is no universal now. There is no single moment that is simultaneously present across the entire universe. The present exists only locally. Everything distant is also past. Every observer exists at the intersection of their own past light cone. You see only events from which light has had time to reach you. Every event you observe has already happened. The farther away it is, the longer ago it occurred. The observable universe is not the universe. It is the portion from which light has had time to reach us since the Big Bang. That portion is vast. It contains hundreds of billions of galaxies. It spans 93 billion light-years from edge to edge. But it is not everything. Beyond our horizon, the universe continues. Galaxies form, stars ignite, planets develop atmospheres. None of this is visible to us. It happens outside our light cone, in regions we can never observe. We are not at the edge of the universe. We are at the edge of our own visibility. The limit is not out there, in some distant location. The limit is a property of being here. Now, in this position, in space-time, there is humility in understanding that most of the universe is inaccessible, not because our instruments are weak, but because of the fundamental relationship between time and space. We occupy a bubble of visibility within something much larger. The universe does not owe us complete access. It continues in all directions, indifferent to observation. We are witnesses to a finite portion of something that may be infinite. The observable universe is 46.5 billion light-years in radius. Beyond that, space recedes faster than light. We will never see past it. This is not failure, it is structure. The universe has placed a horizon around us. We are inside it. That is where we will remain.